the breather. It's the breather. Just the way to relax. We're not going to start our tool. Everything is good so far. Any questions about anything we took so far? This is where, if you get lost and you don't ask, this is where things are going to fly over your head. The stuff that I'm going to talk about, even though it's simple, you have to understand it because it will play a role in everything we learn later. Okay? So let's continue. This is the first slide. I'm not going to talk much about the descriptive and inferential statistics. We talked about them. This is the classical sample picture that we know and love. Random variation. Sometimes things are up to random variation. Sometimes we can't predict where something will lie. In that case, we use probability handles, okay? And we have rules for each single probability. So look, let's say I wanted to find the probability of what someone's length of stay would be in a hospital after a specific surgery. This is the exact example we use. There are some factors I can predict. Maybe females would tend to have a longer length of stay than males. Maybe a smoker would have a lower length of stay or a smaller length of stay. But so you get the point. There are some factors that we can use to predict the length of stay. However, not everything would predict them. Even if I have the exact same twins, sometimes they would have variation. The reason they would have variation is because, like I said earlier, despite being very similar, we also have differences that make us different. Not too different, but slightly different. So we attribute this slight difference as E, which is known as error. Okay? It's something we cannot control, something that's not in our hands, something that is just an error. It encompasses this slight difference between those two exact same people. It gives you the same example, talks about all of these. Okay. These are very important definitions, not just for the exam, but just for understanding it. Probability is the study of chance, how to interpret chance. Now, a sample space consists of all the events that are possible in a given experiment. So I just said a lot of words there. I said sample space, events, I said experiments. So what are events? The best way is with an example. Let's say I toss a coin, or I flip a coin. For it to land heads, that's an event. For it to land tails, that's an event. Heads and tails encompass all of the possibilities of the coin, right? So heads and tails are the sample space. Everyone is clear, right? Sample space, all the events. An event is just a possibility, an outcome of the experiment. So what is an experiment? An experiment is any procedure that has clearly defined outcomes. If I flip a coin, two things are going to happen. Either heads or tails. You spin a spinner, you can get blue, yellow, red, whatever. These are just examples. Here's another example. He makes it a bit more complicated. A 40-year-old woman is diagnosed with diabetes. She reaches her 40th birthday. So the experiment would be, the question would be, what is the chance of her being diagnosed with diabetes before her birthday or after her birthday? So, I mean, this is just a very complicated example. Just stick with the actual flipping the coin. If you have to know this one, it's basically either she gets diagnosed or doesn't get diagnosed before her birthday, or gets diagnosed or doesn't get diagnosed after her birthday. These are all just chances. There are 4 different possibilities. Makes sense, right? But this again is complicated. I just want you to stick with flipping a coin or a die or spinning a spinner. These are much easier for us to understand. Okay, consider tossing a 6-sided die is an experiment. Yes, we talked about this. Find the sample space 1 to 6. All of these are the sample space. We talked about all of this. Okay, did he play this game with you?
Yes.
Yeah. So we're not gonna cover it. It's basically, if you know at least, let's say, 40 people, then you have a 90% chance of any 2 of those 80 people having the same birthday. Of those 40 people, sorry, having the same birthday. This is just an example of how probability can sometimes be conceiving. Probability, when you first saw this question, what did you first think? Probably like 20% or less, right? It's really difficult to find. But probability tells us otherwise. If we actually check the probability, it would be more than 80% of finding 2 people with the same birthday. Okay. Here are our very, very important rules. Okay. I always got confused between, like, let's say probability of A equals, for example, or you know, just forget. Let's just say A. I'm not going to say what this is. Just forget it. This thing equals A times. This is times, okay? The simplest way to explain it. Actually, let me just help you understand what this is. This means both A and B happening together at the same time. This means either one of them happening. Now, I always used to confuse them. So this is a mnemonic, just to help you remember. Imagine there's a spider here, right? The worst spider ever standing. When it's stuck here in this cup, it is stuck between both A and B. It's stuck between both A and B. So you need, this probability encompasses both A and B happening together at the same time. When the spider is here, this means that it can jump either to A or either to B. Easy way to remember it, okay? I know it sounds silly, but if you confuse these, this is an easy mark that you let go in the exam. Now, how do you understand that? Let's say I have a bag with a blue ball and a red ball, okay? What's the chance of getting either the blue ball or the red ball?
50%. What was the question? What's the chance of getting
I swear. Has Dr. Moni ever said to you guys, whoever's recording, could you stop it for just a second? Unfortunately, I'm sorry whoever's watching, but the video for some reason cut out. Genuinely. Okay, I have a bag with a blue ball and a red ball. Okay? What's the chance, if you stick your hand inside, you will get either a blue ball or a red ball? Who says 100, raise your hand. Who says 50, raise your hand. It's 100%. Listen. You have this bag, right? You have this bag. This is the blue ball. I'm going to color it in. This is the red ball, it's not colored in. What is the chance you would, if, let's say you're going to pick out one ball. What's the chance you pick either this one or this one? 100%. You will pick one of them. 100%. You will pick one of them. This is why we add the chance. The chance was half and half. So when you add them together, you will get 1. And what is 1? 100%. Clear?
Yeah.
But I'm just joking when I throw the marker. I did it to the last one. I don't know what they said, because I said, I said 1 times anything, you'll see it soon. I said 1 times anything equals what? And they all said 0. And then I just do this, so it's fine, don't worry. I just do this all the time. But this is really important. You guys understand that, right?
Yeah.
Now, there's more than just this. There's one small little thing that I need to add. We'll get to it when we get to it, okay? But you now understand this. Now, let me do it for both. So, what's the chance that you will get, again, just focus. Don't answer instantly, just focus. What's the chance that you will get a blue ball, then I take it from you, I return it, and then you get another blue ball? What's the chance? Relax. Did I say both or either?
Either.
I said both. What's the chance of getting a blue ball? I take it, I return it, then you get the blue ball. What's the chance of getting both of them? So the first chance, what is it? What's the second chance? Do you multiply or do you add?
Multiply.
How much will it be?
1/4.
1/4 equals 25% chance. Does it make sense?
Yes.
Did it click? I'll repeat it. It's fine. Listen. If you're thinking, oh, Khalid, we're going so slow, just move on to it. If we pass this, the rest is easy. You need to know this. Maybe just, okay, forget this, it's stupid. Either being heads or tails. Are you sure? Yes. Because if I do this, The 1 is the tails, okay? Look, it's 1. It's 1. So that means that we won. And what a surprise we won because it's 100%. Even if it was the other way, we would have won, right? Okay, now this one we might not get it because it's 25%. I gave you the answer, it's 25%. But why is it 25%? You gave me this coin. You asked me, if you flip it twice, what's the chance of both times getting heads? Now, I gave you the answer, it's 25%. So we might not get it now, and it will make sense why we're not getting it now. Okay, because it's 25%, it's not that likely. If we do get it, we're lucky. You understand why, right? Because this is half. I think we're going to lose this one from the beginning. Okay, see, it was tails. See, it was tails. So we already lost. Because we were at the 75%. You get it? So this opens up the new, I opened up a new concept, which is, what is the 75%? It's called the complement. Didn't I say that heads and heads is what we're looking for? Everything opposite to that is the complement. So how much do you think would it be? 75%. Does that make sense? Everyone clear? Son, thank you. Honestly, no, it's fine, it's fine, it's fine. It needs to be more visual, I think. Guys. It's fine, it's fine. I could repeat 1,000,000 times. I am fully fine with it. No, عادي. No, keep. I'm being serious. If you're close to finishing it, tell it. Does anyone else not get it besides her? It's fine. I swear to God, it's fine. Just raise your hand if you didn't get it.
The 75, I think.
Okay, you'll understand it if I do this. I'm going to flip a coin twice. Let's get the sample space. What is the sample space? All the events. I could get heads, heads. I could get tails, tails. I could get heads, tails. Or I could get tails, heads. Right? I might need the coin. Stop, we don't need it.
The coin twice. Consider two different experiments. You're doing it.
Yeah, we're doing it differently. And it's 2 different experiments.
Where does it? Where do we count all the?
Okay, look.
All of
It's the same experiment, but done twice. You get it? Okay. No, let me make it even easier. Let me make it even easier. The probability of getting equals, okay, I can't say A equals heads. Or actually, wait, no, forget it. Well, why do I say A equals, just stop, listen. H T. Does this make sense? H is heads and this is tails. Heads. So, follow me with this. This is our sample space. If we only did the experiment once, this would be our sample space. We have 1 and 2. These are the only events. If we tossed it just once. We didn't toss it once, we tossed it twice. It could be heads over heads and heads, heads and tails. It could be tails and tails, heads and tails, or tails and heads. This makes sense, right? These are all the possibilities. There's no other possibility, right? These are the 4. We're only interested in this one. How many are there?
4.
How many are we interested in?
1.
That's one way. The other way is heads times, I put tails here, but heads times heads. What's the chance of heads happening? 1 over 2. What's the chance of another heads happening? 1 over 2. So we take 1 over 2 times 1 over 2. This is the times, by the way. Different ways, same answer. The only difference between my way and this way is that here I wrote all the sample space, and then I took the one we're interested in over everything. Here, what I did was, I did half times half. I just calculated the probability of this one. I multiplied them together, and I got the same answer. This is calculation way. This is not hard numbers, but this is me doing exhaustive work. I have to write all the sample spaces because sometimes it's not this simple. What if I say I want to throw 10 coins? 10 coins is, I'm gonna do this heads, the tail, and this is heads, tails. It's not gonna finish. Or I can just do this. I can do half times half times half all the way to 10. If we find out what this equals, this will equal something like 1 over 128 or something like this. So the point is, look at how faster this way is. That's why I'm encouraging this way, the spider way. You get this, right?
Yeah.
Everyone gets this? So again, sit down for this one, I don't want the shock to kill me. Okay, we'll use the bag. We'll use the bag because it's more complicated. It's not more complicated. It's the same. It's the same. I have a bag with a blue ball and a red ball in it. You will put your hand and grab one ball, okay? And you will take it out and you'll see the color. Listen very closely. What is the chance that you pick either a red or a blue ball?
100%.
Does anyone want to say 50?
No.
No. We all agree that it's 100%. We all understand this concept, correct? What is the chance that you pick a blue ball, and then again, when I take the ball and put it back, you again pick the blue ball? Who says anything other than 25%? It's fine. If you think that, tell me because we can fix this problem. Okay, we all agree it's 25%. Right? The reason for it, you can write all the sample space. You can write blue, 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 red, red, blue, red, red. We are interested in this one. This is 1 out of 4, which equals 25%. Or we can say, well, picking out the blue ball the first time is 1 out of 2. 1 out of 2. Picking the blue ball again is 1 out of 2. These are happening at the same time. I don't mean at the same time. We want them to happen together. So we'll multiply them, not add them, equals 1 over 4. Same number, just different methods. And I encourage this method, not this method. If you can check your answer with this method, do so. But he might bring you a very big sample space. You can't use this method. You can't rely on this method. You have to rely on this method.
I have a question.
Yes.
In the exam, how do I know which word to apply? The multiplication?
It depends on the wording. The wording is how you need to do it. You can't rely on a specific word. This is the problem. Look, I make it easy by telling you both and either. The truth is, it doesn't come like this. It comes, for example, what is the chance? No, either could work. But both, he doesn't bring both. He says, for example, what's the chance of getting
Heads and tails.
heads and tails? What's the chance of getting heads and tails? And here is the key word. So it just depends on how you understand the question. You have to read and look for the key word you're looking for. It could be, for example, what's the chance of getting a 1 out of 6? A 1 on a die when you throw it. And, okay, this is actually a good question. You all know the 6-faced die, right? 1, 2, 3, 4, 5, 6. What's the chance of throwing the die and getting, for example, a 1 and getting, for example, a heads? So we have 1 over 6 and 1 over 2. What do we do here? What do we put between them? Multiply, because we want them to happen together. Together. What if okay, whoever gets this, really, I'll be happy if you all get this together. What's the chance of either getting 1 over 6 and 1 over 2 of the, 1 over 6 for the die and heads on?
Add
You
them.
add them. So how do you add them? Do we just do this? Do we do 2 over
No,
8?
no.
How do we add them?
We made the.
You make. I'm not
Times
going to
3.
explain this. You all times 3 times 3.
Yeah.
Then this is going to be basically 4 over 6. You all understand this, right?
So 1 over.
1 over 3. Yeah, if you want to simplify more. 1 over 3. You all understand this, right?
Yeah.
Don't make this mistake in the exam. Don't say, yeah, I'll just add them to 2 over 6 or something like that. No, it's going to be 4 out of 6.
But this is an example of them happening together, right?
No, this is an example of getting a 1 over 6 or a heads on a heads. Or.
Why are we doing 2 different experiments?
Adi. It's fine. It's fine. It's fine. It's fine. No. Our experiment is doing two things, which is throwing a die and throw. This is one experiment, but it has two things inside. That's it. Yes. Right. Yes, yes.
What's the probability if they're multiple points I'm gonna get a sum of 7?
A sum of 7?
Yep.
You can't get a sum of 7 with two dice. In two dice. You guys, I absolutely hate you. That's first thing. So a sum of 7. He's made. I like your example. He's saying, what if you throw two dice and you get a sum of 7? So I want you guys to name me all the sums of 7s that could be possible in a sample space. No. We have a die that can give us 6 numbers and a die that can give us 6 numbers, right? So the total we know for a fact it is going to be 36. We have 36 of these. I'm not going to write them. It's going to take too long. It's going to take too long. So we're going to have 36. So now give me all the sums of 7. We can have 6 and 1. We can have 1. We can have 5 and 2. 3 and 4. 4 and 3. 2 and 5. 1 and 6. And then we can flip them as well. We did flip them. What else is there? Is this everything? False?
Yes.
Now just make sure. 5, 2, 2, 5, 3, 4, 4, 7. This is everything. So it is going to be, sorry. So 1, 2, 3, 4, 5, 6. 6 out of 36 is what? 1 out of 6.
What?
6 out of 36.
1 over 6.
1 over 6. Just simplify it. So it's 1 out of 6. It's not? Oh, it's good, huh?
Yeah, it's good.
This will never come! Ever! I can guarantee you. Okay. Now how we make the equation for the complement? If P of A, the probability, look how you understand how to say this, the probability of A happening equals 25%. Now probability is always between, I should really put it like this. Always between 0 and 1, thank you. Always between 0 and 1. Okay? 1 here represents 100%. And 0 represents 0%. Okay? If probability of A happening, whatever the event is, heads or getting a 1 on a die, whatever it is, it's 25%. Then P, A, C, the C means complement, is the exact opposite of this. So how do you find the opposite of this? 100 minus 25 equals this. So 75%. And we call this the complement. The complement is the opposite. Okay?
What is the chance of the event not happening?
Yes.
Not getting 2 heads.
Exactly. What's the chance of not getting 2 heads? Or to make it a lot better wording wise, what's the probability of getting anything but heads and heads? At that point it's 75%. He's asking for the complement. So this is what I explained to you. Remember when I put 1 out of 4? I put heads, and heads, tails, and whatever, 2 more. So 1, 2, 3, 4. I told you that we take the one we're interested in and we put it over everything else, right? The one we're interested in, we abbreviate it with M. And everything else is M. So M here is 1 over 4 equals 25%. This is basically just M over N. I explained it. I don't need to go over it again. This is just a quick example. A living feature dies someday. What's the probability of that happening? 100%, exactly. You don't have to take BEP. 0. If I flip a coin, the outcome is head. 50%. If you have a choice of red, yellow, blue, or green, those are 4 choices, and we only want red. So 1 out of 4. So that is going to be So this is one way of determining it. Yeah, I told you. So this is one way. This way does not always work because he might give you 36 different possibilities. And unfortunately, you can't write them all. So just use the calculation way. If he's telling you one way to do it is write all the events, then pick the events you want, put those as m, and everything is n over n, that gives the probability. Toss a fair coin. Yeah, see? Toss a fair coin twice. Whoever was confused about experiment, toss a fair coin twice. It is considered as one experiment. Tossing a fair coin twice, this is one experiment. Tossing a die and tossing a coin, this is also one experiment. One experiment. It just has different parts to it. It has the die component and has this component. At the end of the day, it's an experiment.
How would the wording be for two different experiments?
No, they would just tell you, we tossed a die and we tossed a coin. What's the chance of the die being 1 out of 6 and the coin being heads out of tails? Or what's the chance of this being this or this being this? This would be the spider out of the top. So this is the example we talked about. This is why it became 0.25. I don't want to spend too much time on it. He might give you like something like this. This is just testing your concept of complement. He gives you the probability of surviving in the first year, a child surviving in the first year. He tells you, we have 100,000 and 99,149 times they survived. So what's the chance of them not surviving?
1 minus the
Yeah, 1 minus that, and it'll be a value. You have a calculator, just do it during the exam. Again, you can take frequencies and probabilities. So this is just, if I have 7 students who never took a math course, and then I have them inside this hall, if I ask a random one, what's the chance of them saying I don't? You just put 7 out of them all, which is 7 out of 55, which is 20% chance. So again, this is just probability over and over again. He loves putting, this is just representing it in a bar graph sort of way, bar chart. Probability needs to be between 0 and 1. We discussed this. Probability of an event cannot happen is 0. Yes, sorry. Thank you so much. Right. See, here. It's just, for the exam, the purpose, remember I told you the probability of someone being 60 feet tall, you told me it's impossible? For the purpose of the exam, but look, I'm telling you, forget the exams for a second. This statement, the probability of an event sure to happen, the example is wrong. Friday comes after Thursday, you don't know. Maybe someday in the future, they make Thursday after Friday. You don't know. Maybe they say, the Gregorian calendar, they say, no, we want Friday to come before Thursday. So my point is this is not true. I don't want you thinking like this when you think of statistics. Statistics should be, there's nothing called 100% or 0%. For the sake of the exam, don't listen to me. Just put it 100% and 0%. But for the sake of understanding the final material, you have to put your mindset not to follow something like this. Okay, so this is a very important one. It's written right up there. So if I did something like this. Or no, you know what? What's the chance of me getting heads? Okay, one throw of the coin. What's the chance of getting heads and tails? Absolutely impossible, right? There's no way I can get heads and tails. Even if it stands on its side, that's still not considered heads and tails. That's considered something else. You redo the experiment. So you get it, right?
Yeah.
The complement and the probability and its complement can never happen at the same time because they are exact opposites. However, the probability and its complement, the probability or its complement happening is what? 100%. Either getting a heads or a tails is what? 100%. They're complements, right? So it doesn't surprise us that it should be 100%. Clear? So this statement up here, if it says here, heads, this is actually perfect. I don't know why I did. No one even noticed this. Because I said heads and tails. But no, here I said, but yeah, this is very important. This is true. I know you're saying, Khalid, you just said if it's heads and tails, it's false. Here it's